Hi students, welcome to this session. In this session we are going to see 10th Science Unit 4 Electricity. Content of the session: electric potential and electric potential difference, Ohm's law and resistance of a material. Now what is electric potential and potential difference? To understand the electric potential, first we have to understand some concept. Look at the picture. The first picture I have given, two glass beakers are connected with a tube. Can you tell me the water can flow from beaker 1 to 2 or beaker 2 to 1? Can anyone say? No, the water cannot flow from beaker 1 to 2 or 2 to 1. What is the reason? Because both the beaker, the water level is same and the tube is also connected at the same height. So, the no water flow from beaker 1 to beaker 2. Now, I am going to ask you a question. You make the water to flow from beaker 2 to 1. What will you do? Yes, you have to increase the height of the beaker 2. When you increase the height of the beaker 2, what happens? When the height of the beaker increases, the pressure level also increases. So, we know the water flow from high pressure level to low pressure level or higher level to lower level. So, the height difference, when you increase the height, makes the level of the pressure high. So, the water flow from beaker 2 to beaker 1. How it is related to the electricity? For the flow of electrons also needs the difference in the pressure level. That means that is known as the potential. Okay, when electric potential is large, then the electrons flow from higher potential to lower potential. Can you understand, students? So, now let us see what is electric potential at a point. Now you have to imagine a unit positive charge is at infinity. You have to bring the unit positive charge from infinity to a particular point. Now look at the diagram. Now you have to bring the unit positive charge which is at the infinity to point A. When you bring the charge to A, you have to do a work. That work also we have to do against the electric force. That means positive charge, suppose it moves means have to bring from right to left. That means you have to bring towards the A. At that time you have to do a work. That amount of work done is known as the electric potential at a point. Can you understand that concept, children? Yes. What is electric potential at a point? The amount of work done in moving a unit positive charge from infinity to that point against the electric force. So, you have to remember, when we bring the charge against the electric force, we have to give an external force. That means when we are giving the external force, we are doing a work. Okay, that amount of work done, that is the electric potential. Now, let us see the electric potential difference. Here, what is the difference between electric potential and electric potential difference means? In the electric potential, we move the positive charge from infinity to a particular point. In this one, we are going to make the difference between the 2 points. Okay, we have to bring the unit positive charge from point A to point B. When we move the charge, at the time there is a loss of energy. Okay, that is the potential difference. Okay, now we can see the definition. We have to move the unit positive charge from A to B. Okay, from the point A to B. That also, here also we are doing the work against the electric force. Okay, children. So, at the time we are giving the work, moving a charge from one point to another point, we are doing a work. That amount of work done is known as the electric potential difference. So, now let us see the proper definition. The electric potential difference between 2 points is defined as the amount of work done in moving a unit positive charge from one point to another point against the electric force. Can you follow, students? Yes. Now let us go to the formula of the electric potential difference. Now let us take the charge of the sphere, that means charge of the point. Now let us take the charge of the sphere is equal to Q. Now we have to move the charge from point A to B. At the time what I told you, we have to do a work. So the work done to move the charge from point A to B is equal to W. Next, what is the potential difference between the points A and B? The potential difference is denoted by the letter V. Okay, so the potential difference between the points A and B, V is equal to work done W by charge Q. Can you follow, students? We have taken charge of the sphere is equal to Q. Work done to move the charge from point A to B is, yes, that is W. So the potential difference between the points A and B is equal to work done by charge. Now let us go to the definition by assuming the 2 points. That means we have taken the point A and the point B, isn't it? Now let us take the potential at the point A as VA and the potential at the point B as VB. Now we can see the formula for that. Potential difference is also equal to the difference in electric potential of these 2 points. This point already I told you, when we move a charge from point A to B, there is a loss in the potential. Okay, that is the difference. That is electric potential at point A is VA, I told you. Electric potential at point B is VB, I told you. The difference in the electric potential at A and B gives the potential difference, that is between the points A and B. So V is equal to VA minus VB when VA is more than VB, or V is equal to VB minus VA when it is happen VB is more than VA. Can you follow, students? Once again I will tell you, potential difference is also equal to the difference in the electrical potential of these 2 points. That means if electric potential at point A is equal to VA, electric potential at point B is equal to VB, then the potential difference between the points A and B, V is equal to VA minus VB, or V is equal to VB minus VA. The first case, that means VA minus VB, if VA is more than VB. In the second case, that is VB minus VA, that is if VB is more than VA. At point VB, the electric potential is more, then potential difference V is equal to VB minus VA. Can you follow, students? Yes. Now we can see the SI unit of potential difference and the definition based on the units. What is the SI unit of electric potential or potential difference, which is equal to volts? It is denoted by the letter capital V. Now let us see the definition of the potential difference between the 2 points using the units of the potential difference, work done and the charge. You recall the units, children. What is the unit of potential difference? Volt. What is the unit of work done? Yes, it's joule. What is the unit of charge? Yes, it is coulomb. Now we can go to the definition. The potential difference between 2 points is 1 volt. Okay, if 1 joule of work is done in moving 1 coulomb of charge from one point to another against the electric force. Can you follow? Now we have to bring the positive charge. Okay, 1 coulomb of charge from one point to another point. Okay, at the time what work is we are doing? 1 joule of work is done to bring the charge. Okay, so the potential difference between 2 points is 1 volt if 1 joule of work is done in moving 1 coulomb of charge from one point to another against the electric force. This is the definition for the potential difference using the units. So you have to remember 1 volt is equal to 1 joule per 1 coulomb. Now let us go to the problem based on the potential difference. Look at the problem, children. The work done in moving a charge of 10 coulomb across 2 points in a circuit is 100 joule. What is the potential difference between the points? Now, already I told you, whenever you are doing the problem, first thing you have to write the given part. What is given? The charge is given, which is equal to 10 coulomb. And then amount of work done is given, which is equal to 100 joule. Now, next step you have to write the formula for the potential difference, which is V is equal to W by Q. The next step you have to substitute the values. That means W is equal to 100 joule and Q is equal to 10 coulomb. So, 100 by 10. So, the answer for the potential difference V is equal to 10 volts. Can you follow? Shall we go to the next topic? Yes. Now, we are going to see the very important topic of this lesson, that is the Ohm's law. This was established by George Simon Ohm. He established the relation between the potential difference and the current. When the current flow through the circuit, okay, there is a potential difference occurs in the circuit across the resistor. So, when the current increases, the potential difference also increases. This was his statement. That is, I is proportional to V. That is, current is proportional to potential difference. Now, the picture, the circuit which you are seeing in the slide is used by the circuit which is shown in the slide is used by George Simon Ohm to prove his law. Okay, children. Now, we are seeing the circuit diagram which is used by the George Simon Ohm. In this diagram, look at the components used by him. B refers, yes, battery. K refers, key. RH refers, variable resistor. And XY refers the resistor, that is unknown resistor. V denotes the voltmeter and A denotes the ammeter. Now, what he did in this experiment? He adjusts the amount of current by using the variable resistor, that is rheostat. When he adjusts the amount of current flowing through the circuit, he could find the potential difference across the resistor. Then he noted the readings. Okay, at that time, after doing the experiment, he found whenever he increases the current, the potential difference also increased. Then he concluded that I is proportional to V, that is the current is proportional to potential difference. Then only he designed the statement, Ohm's law. Now let us see the law. According to Ohm's law, at a constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference V between the two ends of the conductor. This is the statement, children. You have to remember that. The three things you have to remember in this statement. The first one is the at a constant temperature. Okay, the temperature is constant throughout the experiment. So, you have to write at a constant temperature. Then, the steady current, the current flowing through the circuit is not a variable current, that is the steady current. You have to note the word steady current. Okay. So, steady current I flowing through a conductor is directly proportional to the potential difference V between the two ends of the conductor. Here the conductor refers the unknown resistor. We used XY, that is the unknown resistor. Okay. So, I is directly proportional to V. Hence, I by V is equal to constant. This was the law established by George Simon Ohm. Now, let us see the value of proportionality. To remove the proportionality, we have to introduce a constant term. Okay. So, the value of the proportionality introduced by George Simon was 1 by R. So, the value of this proportionality constant is equal to 1 by R. Therefore, I is equal to 1 by R into V that is V is equal to IR. Here the IR is known as the resistance of the material. That means the unknown resistor we used, at that material's resistance is referred as the R. The value of R is constant for a given material at a given temperature. That should be keep in your mind. The value of R is constant for a given material at a given temperature. Can you follow, students? Once again we can recall the law. The statement, according to Ohm's law, at a constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference V between the two ends of the conductor. That is I proportional to V, hence I by V is equal to constant. The value of the proportionality constant is equal to 1 by R. Therefore, I is equal to 1 by R into V. That is V is equal to IR. R is known as the resistance of the material and the value of R is, yes, constant for a given material at a given temperature. Now, what is resistance of the material? This one we are going to see. To understand the resistance of the material, again we have to recall the experiment done by Ohm. Okay, in that what he found? When the current flow through the circuit, the potential difference varies, isn't it? That one he found in the experiment. Now, to understand the concept of resistance of a material, what we are going to do? Now, first we can take the unknown resistor. For different materials we have to take. That means, first readings எடுக்கிறப்போ, what we can do? நம்ம nichrome எடுத்துட்டோம்னு வெச்சுக்கோ. Nichrome is an alloy. Okay, nichrome use பண்ணி we have to take the ammeter reading and the voltmeter reading. அதாவது voltmeter reading we have to make it constant. Voltmeter reading we have to keep it as a constant வெச்சிட்டு we have to check the ammeter reading. Then you have to change the material of the resistor. இப்போ nichrome க்கு பதிலா copper material எடுத்துக்கலாம். Copper எடுக்கிறப்போ we have to maintain the potential difference வந்து சேமா வெச்சுக்கணும். nichrome க்கு என்ன potential difference கொடுத்தோமோ அதே potential difference தான் maintain பண்ணிட்டு then we have to check the current flowing through the circuit. Next என்ன பண்ணனும்னா we have to change the, instead of copper we can use the aluminum. Aluminum use பண்றப்போ now again we have to maintain the same potential difference. Okay, but the amount of current என்ன அப்படிங்கறத we have to check. இத செக் பண்றப்போ நமக்கு என்ன தெரியும்? Ohm's law படி என்ன தெரியும்? V by I constant ன்னு இருக்கணும். But we have used here three different materials. One is nichrome, another one is copper, the last one is aluminum. ஆனா மூணு மெட்டீரியலுக்குமே பார்த்தோம் அப்படினா V by I ஓட வேல்யூ, that is the resistant value differ. இதிலிருந்து நம்ம என்ன அண்டர்ஸ்டாண்ட் பண்ணிட்டோம் அப்படினா resistant differ for different materials. So resistance is nothing but it is the property of a material. Okay, it is the property of the material to oppose the flow of charges. Okay, current உள்ள வரப்போ என்ன பண்ணும் அப்படினா ஒவ்வொரு மெட்டீரியலுக்கும் அந்த flow of charge வந்து oppose பண்ணக்கூடிய ஒரு ப்ராப்பர்ட்டி உண்டு. That property is the resistance of the material. Can you understand, children? Yes. Now let us see the definition of the resistance. Resistance of a material is its property to oppose the flow of charges and hence the passage of current through it. Do you follow? Yes. Already I told you it is different for different materials. From Ohm's law, V by I is equal to R. The resistance of a conductor can be defined as the ratio between the potential difference across the ends of the conductor and the current flowing through it. Now, can you understand the definition, children? The resistance of a conductor can be defined as the ratio between the potential difference across the ends of the conductor and the current flowing through it. Do you follow? Yes. What is resistance of a material? Yes, it is the property to oppose the flow of charges. Now, let us go to the unit of resistance. The SI unit of resistance is ohm. It is represented by the symbol omega. To honor George Simon Ohm, the SI unit of resistance is given as ohm and it is represented by the Greek letter omega. Now let us see the definition of the 1 ohm using the units of potential difference and the current. Again we can recall the units. What is the unit of current? Yes, 1 ampere. What is the unit of potential difference? Volt. What is the unit of resistance? Ohm. Now we are going to see the definition of the 1 ohm. What is 1 ohm is known as? That is the resistance of a conductor. Okay. So resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when a potential difference of 1 volt is maintained across its ends. Can you follow, children? Yes. What is the definition? Let us recall the definition once again. Resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when a potential difference of 1 volt is maintained across its ends. So 1 ohm is equal to 1 volt by 1 ampere. Can you follow? Yes, children. We can go to the problem based on the Ohm's law. Now look at the problem. Calculate the resistance of a conductor which through a current of 2 ampere passes when the potential difference between its ends is 30 volts. Now what you have to calculate? You have to calculate the resistance of a conductor. What is given? Current 2 ampere is given. Potential difference between the ends 30 volt is given. Now we know the formula for resistance. Resistance R is equal to V by I. Now we have to substitute the values. 30 by 2 which is equal to 15 ohm. Okay. Again I am reminding you, whenever you are doing the problem, first thing you have to write the given, second thing you have to write the formula, and the third one is the substitution part. Now let us go to the evaluation part, children. What is electric potential difference? The electric potential difference between 2 points is defined as the amount of work done in moving a unit positive charge from one point to another point against the electric force. That means we have to bring the unit positive charge from one point to another part. For that we are doing some work. That amount of work done is known as the electric potential difference. Again we can see the answer. The electric potential difference between 2 points is defined as the amount of work done in moving a unit positive charge from one point to another point against the electric force. Second question, state Ohm's law. According to Ohm's law, at a constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference V between the two ends of the conductor. That is I proportional to V. In this you have to remember, you have to write at a constant temperature, and then you have to write the steady current I. Next you have to write the directly proportional to the potential difference between the two ends of the conductor. So you have to highlight the words constant temperature, steady current, and then potential difference V. So I proportional to V. Now let us see the definition again. According to Ohm's law, at a constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference V between the two ends of the conductor, I proportional to V. Now third question, define 1 ohm. That is, the definition is based on the units of potential difference and the current. Okay. Now resistance of a conductor is said to be 1 ohm if a current of 1 ampere flows through it when a potential difference of 1 volt is maintained across its ends. So 1 ohm is equal to 1 volt by 1 ampere. Now let us go to the next question. Define 1 volt. This definition also based on the units of work done, charge and the potential difference. The potential difference between 2 points is 1 volt. If 1 joule of work is done in moving 1 coulomb of charge from one point to another against the electric force, 1 volt is equal to 1 joule per 1 coulomb. So for this session, we have seen the electric potential at a point, that is the amount of work done in moving a unit charge from infinity to that point against the electric force. Next we have seen the electric potential difference between 2 points, that is the amount of work done in moving a unit positive charge from one point to another point against the electric force. The third one, we have seen the SI unit of electric potential or the potential difference, which is volt, denoted by the letter V. Next we have seen the statement of Ohm's law, that is I proportional to V. The next one we have seen is the resistance of a conductor. It can be defined as the ratio between the potential difference across the ends of the conductor and the current flowing through it. The SI unit of resistance is ohm and it is represented by the symbol omega. So for this session, we have seen what is potential and the potential difference and the statement of Ohm's law, and what is resistance of the material and its SI units. Can you understand, children? Thank you.